All right, welcome to The Explainer. Today, we're diving into a piece of tech that's, well, it's kind of quietly changing everything by making a perfect digital copy of the real world. We're talking about the digital twin. Okay, just think about this for a sec. What if a whole factory could tell you it was about to break down and stop it from happening? What if a jet engine could literally tell you, hey, I'm gonna need a new part in 3 weeks? Or what if an entire city could run through an emergency plan before a disaster even hits? I know, it sounds like something straight out of a sci-fi movie, but this isn't the future. It's happening right now. And the way it's all possible? Yep, the digital twin.
All right, so what in the world is a digital twin, really? Let's get right into it and break down what this actually means.
So on the surface, a digital twin is just a virtual version of a real-world object or process. Simple enough, right? But here's the absolute game changer, that phrase, in real time. This is not just some static 3D model you look at once. No way. This is a dynamic, living replica that's constantly being fed live data from its physical counterpart. The easiest way to think about it, it's like a living, breathing virtual mirror. Seriously, whatever the real object does, its digital copy does it too, at the exact same moment. It feels what it feels, it goes through what it goes through. They are perfectly in sync. Okay, I know that sounds pretty complicated. So how does this whole thing actually work? Let's pop the hood and see what makes this technology tick. So you've got a few key pieces. First, you have the actual physical thing, right? Let's say it's an engine. Then you cover that engine with all sorts of tiny IoT sensors. These things are constantly gathering data, everything from temperature to vibration to speed. All that data gets zapped over to the system's brain, which is usually some form of AI that crunches all those numbers. That AI then updates the virtual model, the digital replica. But, and this is the really cool part, it's not a one-way street. It's a two-way connection. The virtual model can actually send insights or even commands back to the real engine to make it run better. So, if you were to build one, the lifecycle kind of looks like this. First, you stick sensors all over the real-world asset. Step 2, you build its virtual clone. Then, you let the AI analyze that non-stop flood of data coming in. And finally, this is where the magic really happens. You create that feedback loop. The twin isn't just a passive observer, it's an active participant. It advises, it predicts, and sometimes it can even take action all on its own to make things better. Now, you might be thinking, hang on, isn't this just a really fancy simulation? And that's a great question, but the answer is a big no. The difference is absolutely crucial. A simulation, that runs on static, made-up data to test what-if scenarios. But a digital twin, it runs on live, real-time data. It's not showing you what might happen, it's showing you what is happening right this second. Think of it this way. A simulation is like a weather forecast. A digital twin is like a live Doppler radar that's so advanced it can tell you exactly where every single raindrop is. Okay, that's enough theory. Let's talk about the real world. Where is this technology actually being used to change the game today? Let's start with manufacturing. Take BMW. They've built a digital twin of their entire assembly line, the whole thing. So now they can see in the virtual world that a specific robot arm is vibrating just a little bit too much, and they can predict it's going to fail in about, say, 72 hours. So they can go fix it before it ever breaks down. Imagine the amount of money and time that saves. How about aerospace, where you can't afford any mistakes? Well, Rolls-Royce creates a digital twin for every single jet engine it sells. Every one. They can monitor that engine's health, its fuel efficiency, and the wear on every component, all in real time, while it's 30,000 feet in the air. This lets them schedule maintenance with unbelievable precision, making flying safer and more efficient. And we're not just talking about single objects anymore. We're talking about entire systems. The whole city-state of Singapore has a digital twin called Virtual Singapore. It's a complete 3D replica. So city planners can test out new public transit routes, figure out the best way to manage energy during a heat wave, or simulate emergency evacuation plans, all in the virtual world before they spend a single cent in the real one. But this one might be the most incredible of all. Healthcare. Doctors are now creating digital twins of human organs. Imagine a perfect virtual copy of your heart. A surgeon could practice a complex operation on your virtual heart a dozen times before ever making an incision. They could test how your specific body would react to a new drug. This is the dawn of truly personalized medicine. So these examples are pretty mind-blowing, right? But believe it or not, we're really just scratching the surface. So what's next? Where is all of this heading? Well, first, let's be real about the challenges. This stuff isn't easy. It takes an insane amount of computing power to run a detailed twin. And think about the cybersecurity risk. If someone hacks the digital twin of a power grid, that's a huge problem. And of course, when you start creating digital twins of people or entire cities, you run into some really serious questions about data privacy and ethics. But the future trends here are just wow. Technologies like 5G are going to make the connection between the real and virtual worlds almost instantaneous. Digital twins will almost certainly be the foundation of the metaverse, whatever that ends up looking like. And then there's the holy grail, the autonomous twin. A twin that doesn't just predict a problem, but can actually learn and figure out how to fix it, all by itself.
And this quote really nails the ultimate vision. It's not just about watching. The real goal is to create a closed-loop system. Basically, a world where the physical object and its twin are in this constant, automated dance of improvement, making each other better moment by moment.
So, let's wrap this up with a big question to chew on. As these digital copies get more and more perfect, so perfect that they can predict the future of the original and even improve it, what does that say about the original itself? What makes the real thing unique anymore? That's a pretty deep question we'll all have to think about as our physical world gets its very own, very smart digital mirror.